Greetings everyone, this is Charles with Phenomware, and in a prior video we talked about computer science and what it is and why I feel it's important that we teach it. We also talked about the tech industry and the fact that it's booming with jobs for computer science majors. So in the next few videos we'll hop on my computer and take a look at some of the articles I found, and these videos will showcase how computer science has advanced a few industries over the past decade. So let's get started. So I'm going to start with agriculture, and basically agriculture, I got this article from careerswithcode.com, and I'm just going to read a few sentences that I snipped away from the website. So in agriculture, how is computer science affecting that? Well, nestled in California's Central Valley, the breadbasket of the country, a tractor rolls through a field with nobody at the wheel. But it's not an accident. It's one of many robots used in agriculture. Built by Blue River Technology, this robotic tractor uses a technique called machine learning. The equipment learns how to tell weeds from crops and how to tell healthy plants from those that are struggling. The company says farmers will use 90% fewer chemicals by only spraying the plants that need it. It's a tricky technique, but it's one that Blue River thinks is worth mastering. So this is pretty cool because they're basically using machine learning, and machine learning is basically just a subset of artificial intelligence, where, just like I was explaining before, that this tractor is able to learn the different types of plants and can tell the difference between them, and there's no one even driving the vehicle. So this is pretty significant, and it goes to show how computer science is affecting agriculture. I mean, you would think that farming and agriculture really hasn't changed over the past, 30 years, but pretty amazing technology being used right here just for agriculture. All right, next up, architecture. Now this one's a little bit different than some of the other examples I'm giving because it's not completely related to computer science in that sense, but I think it's the most recent advancement for architecture, and that is virtual reality, augmented reality, and mixed reality. Mixed reality is pretty much like augmented reality because it mixes 3D elements into the real world. So some people call it mixed reality, but I'm just going to say VR and AR basically. The difference being that virtual reality is where you put on a headset and it sort of immerses you in a different world. You're no longer seeing the environment that you are sitting in. So if you're sitting in a room, you put a VR headset on, you're going to see whatever experience was created by the developer or designer for that headset. So HTC Vive, Oculus Rift are the top two headsets for virtual reality right now. But augmented reality, there's quite a bit of augmented reality going on, which is the opposite, which is actually you look through your device, whether that's a headset or a phone, and you see the world that you are in through your camera, but you augment or you have three-dimensional objects that show up in the real world. So in this picture, they're using Microsoft Hololens, which has a developer build, and so they're able to put these headsets on, and they can see, obviously, this table. In reality, they can see each other. In reality, they can, just peer through the glasses and see each other, but they can also see a three-dimensional object. This is kind of like holographic Star Wars stuff and Star Trek stuff. So that's basically the idea with augmented reality, that you don't submerge yourself or immerse yourself into an environment completely. You're still in the real world, but there are augmented objects right in front of you. So why did I mention this in a topic about computer science? Well, obviously programmers had to design with the engineers design this technology, and it's really changing architecture. It's enhancing architecture. Architecture has always been 3D design on a computer, and it's been somewhat of a 2D barrier. But with virtual reality and augmented reality, everything changes. I mean, can you imagine what type of meetings they're having here with these headsets on? And there's a lot of opportunity for people who are in computer science to be able to program and develop for these headsets. So it's pretty amazing. And architecture is a great fit for both VR and AR. This article is pretty long. I'm not going to read it all, but basically a couple of sentences from this article state across the U.S., architecture firms are beginning to incorporate virtual reality into their practices at a fast clip. But for the VR uninitiated, wrapping one's head around the technology and what it differentiates it from the other technologies that accompany it, like AR or mixed reality, can feel overwhelming. Even experts will confusingly use these terms interchangeably. But why? Well, it's because of the nature of the technology. All VR/AR starts in the same place, a model in 3D. VR and AR are both ways of experiencing the model outside of a screen. That's all I'm going to read. This is awesome technology. I'm pretty excited about VR and AR. I actually have an Oculus Rift, so I'm pretty excited about developing for it. All right, next up. We're actually going to talk about automotive. So obviously this was pretty straightforward. We know that smart cars are basically the new technology in terms of automobiles. It seems like we have advanced every field to smart toaster, to smart washing machine, to smart door locks, to smart cameras, you name it. But the car seems to be the one that just has not gotten there yet. I think obviously the electric cars, especially Tesla, and some of the others are leading the way in the charge to get cars on board with everything else that's smart. But obviously you don't want a smart car that hasn't been thoroughly tested, especially the newer cars that are self-driving. So this is a pretty major move right now. Is really I think this is going to take a significant amount of time to test and get right. But here's a particular article that talks about the smart car algorithm that sees pedestrians. So the artificial intelligence used here, as you can see in this article, shows the detection of people in these different photos, and they obviously have a video here that they're showcasing. I pulled this off of Engadget, but I think they actually referenced it from somewhere else. But yeah, the article basically says you need your car to spot that jaywalker in time to avoid a collision. Thankfully, UC San Diego researchers have made that more realistic than ever. They've crafted a pedestrian detection algorithm that's much quicker and more accurate than existing systems. It can spot people at a rate of 2 to 4 frames per second, or roughly as well as humans can, while making half as many mistakes as existing systems. That can make a difference between a graceful stop and sudden scary braking. So, it's great that UC San Diego researchers are doing this. They're using a lot of deep learning and machine learning. But basically, that just means that they're using computer science and programming to run algorithms that detect the people. And it's obviously using cameras and all sorts of sensors to detect those people. Also another great use of computer science. I hope my videos are informative, that you can learn from them, and that they are enjoyable to watch. If so, get real familiar with that like button and make sure to subscribe to my channel. Stay tuned for the next video.